Hello, in this lesson you will learn the basic algebraic formulas, factorization, and factorizing polynomials. So let's get started. First, we will talk about basic algebraic formulas. So formulas are a general solution for the same type of algebraic questions. These are very helpful in simplifying algebraic expressions. They can also be used for factorization of algebraic expressions. These are the three basic algebraic formulas. On the basis of these formulas, we will be able to factorize the algebraic expressions. Let's solve a few examples to see how this formula works. We have this example. In the example, if a minus b equals 5 and a plus b equals 7, then we have to find a square minus b square. So let's get back to the formulas. The formula number 3 is applicable to this example. Let's see how it works. A square minus b square equals a minus b into a plus b. Now simply put the values in this formula. A minus b we have 5, whereas a plus b we have 7. So the product of 5 and 7 gives 35. So a square minus b square equals 35. This is how formula works. Now we have another example in which states that if x plus 1 over x equals 10, then find x square plus 1 over x square. So let's write down x plus 1 over x equals 10. Let's square both sides. So if we compare this term with formula number 1, we see that a plus b whole square equals a square plus 2ab plus b square. So write that, so evaluate this formula now. It will become like this: a square, in place of a square we will write here x square plus 2ab. In place of 2ab we will write here 2x into 1 divided by x plus b. In place of b square we will write here simply 1 over x square equals, and 10 square gives 100. So it will become like this: x square plus 1 over x square, and it will get cancelled with each other. So we'll have 2 over here equals 100. So x square plus 1 over x square equals 100 minus 2. Here 2 is plus, and here it will become negative. So the final answer will become like this: 98. So this is how this formula works. Now I have slightly complex example. We have to find x4 plus 1 over x4. If we have x minus 1 over x equals 5. Let's write it down again: x minus 1 over x equals 5. So we will square both sides. So it becomes, we can apply formula. We can apply this formula: a minus b whole square equals a square minus 2ab plus b square. Remember this formula. So it will become like this: x square minus 2 times x 1 over x plus b square. In place of b square we will write here 1 over x square equals 5 square gives 25. So it will become like this now: x square plus 1 over x square. These both will get cancelled with each other, and minus 2 equals 25 x square plus 1 over x square, and shift the 2 to the right side of the equality. So here it is negative, it will become positive over here. So it will become like this: x square plus 1 over x square equals 27. Now square both sides again. So x square, now here we can apply this formula: a plus b whole square equals a square plus 2ab plus b square. I hope you remember this formula. All right, x square plus 1 over x square, so it will become whole square now, like this, plus 2 times a dot b equals 27 square gives 729. Yes, it gives 129. So it will become x4 plus 1 over x4 plus 2. These both will get cancelled with each other, equals 729. X4 plus 1 over x4 equals 729, and shift the 2 to the left side, to the right side. It will become negative over here. X4 plus 1 over x4 equals 727 is the final answer with us. Now that we have learned how to apply the formulas, we are excited to do some factorization. So remember that formulas are helpful in simplifying lengthy and difficult algebraic expressions. Instead of performing the usual process of fundamental operations of division or multiplication, not necessarily, but generally we have five uh, forms of algebraic expressions. The first one is Ka plus Kb plus Kc. Now what does it mean? It means that we will be given an algebraic expression, and we will have to factorize that, and maybe that follows this form. So let's see how we can solve an example. Suppose we have 3a plus 6b plus 3c. So now you can compare it with this expression with the general form. This is Ka plus Kb plus Kc. So what we can do with this? Now we will take a common from all of from the whole expression, like this. It seems that we can take 3 as a common from the whole expression. 3, here we have just a now, here we have 2b now, and here we have c now. So this is how you can solve an expression with the help of this with the help of this general form. Another form might be AC plus AD plus BC plus BD. So we can solve an example with the help of this general form. The example is 2a plus 2b plus 3a plus 3b. Since we cannot take one term for a common, one term as a common from the whole expression, so we will divide it into two halves, like 2a plus 2b is one half, plus 3a plus 3b is another half. Now it's quite simple. Take 2 common from this side, and here we will have a plus b, and take 3 from this side, and we will have a plus b over here. So we can simplify it further like this. Take now ab from the whole expression, like this, a plus b, and take 2 plus 3. Now we have 5 times a plus b. Now we can think of a formula that best fits this expression, and that formula can be a plus b whole square equals a square plus 2ab plus b square. So now we have to evaluate this expression according to that formula. So we can write 100x squared as 10x whole square. We can also write this term as 2 into 10x into y plus y whole square. So now if we can compare both the formula and this expression, so it gives us like a square plus 2ab plus b square. So that formula is a plus b whole square, right? So according to this formula, we can write the above expression as 10x plus y whole square, all right? So we can further evaluate this as 10x plus y into 10x plus y. So this is the required answer. Another example, according to the general form a squared minus b squared might be x squared minus 9. We can write this as a squared minus, we can write 9 as 3 square. So it's now a square minus b square, so we can write this as x minus 3 and x plus 3.